Thank you, Phil, to invite us to present here, and thank you, Jackie, to chair this session. It's my honor to have the opportunity to present our results in Arctic Ocean to all of you. My topic is spatial distribution of sea surface chlorophyll from Berlin Sea to Czech Sea and the impact effects analysis during the summer of 2014. And now actually I add some results of 2016 now, so we will see it. So why we select this as our indicator, as the describer of the ecosystem? Because it's our primary production for the oceans, and we all know this, that the chlorophyll aid is a very important indicator and easily can be monitored with many methods. So we select this as our topic and our key indicators to do some primary research on these issues. This map I have shown by Jackie and other professors already on these meetings. And why we select this region? Because our research vessel, Xuerong, is it's a normal way for its cruise every 2 years now from Shanghai to Arctic Ocean and back. So this is the original research area of Chinese polar research in Arctic. So we will see that this is already taken, and now this summer now is the 7th Arctic cruise in normally during July to September. And the data series used today to present is this summer. For 2 years ago, we have selected some data series and do some analysis. And also we have learned some methods from this meeting to analyze our data from this year. So it will be more fruitful and calibrated by other methods and some like DBO systems data maybe. So this is why we select this area. So this is what we used in summer of 2014. This is where we depart from Shanghai here in the altitude of 30 degrees. Then we go to this basin, Canal Basin, and about across the 50 degrees. What I will show you here is that the ocean doesn't have boundaries. So maybe we sometimes should look at the questions or the problems in more broad views, not only the Arctic itself. So that's what we want to show. And the fish also don't have boundaries. They can swim in there without any boundaries. So we will take this data analysis from this is the going and this is the back way, and the different time. Normally we depart at the middle of July and back in the end of August and arrive in Shanghai in September. So 2 months is 60 days, normally every 2 years. So this is a variable data set we have, but until now, only data set, not a result, because we needed to calibrate it and with some modern modified methods. So this is our sampling on the vessels for this presentation, the result, and we have the high frequency monitoring for every 30 seconds from Shanghai, the 30 degrees north, to the 80 degrees north. And we also have the data from Shanghai to Antarctic. So our vessel is sailing every year like North Pole to South Pole. So collected a lot of data, but now we needed to have some data mining work to do it as a research result. So that's the work we are doing now. Another way is that we now are thinking about what we talk about the human activities to be managed, but it is really affected by human activities only, or it is a natural process plus human activities, some as the change of the soil, radiation, something like this. So we will combine these several indicators together to describe our speed distribution of this. So this is the long way from the Shanghai to across the Japanese Sea and Bering Strait and the Arctic Ocean. So this is north than 50 degrees in the summer of 2014. And we compare this result with other reference and to see the change about from the Brindisi Basin to Brindisi Shelf, Trick Sea, and the Canada Basin. You will find that from the south to the north, it's decreased of this chlorophyll. It's similar to the result from JKZ that during the summer, it's the flow of the ocean currents from the south to the north, and not as the spring bloom. They are limited nutrients from south and the north because it's bring by the ocean currents, normally from the Pacific, North Pacific. It's interesting that we start this. This is 2 years before, and this is this year. So you will find some difference with even every year at the same time is different, and with different of this salinity and temperature and chlorophyll, because we have this high frequency monitoring together at the same time for every 30 seconds. So we have huge data to modify it and to analyze it. You will find the most highly ones is in this area. It means the two ocean currents bring more of nutrients and to bring more chlorophyll, not other factors as human activities. So we combine several limited indicators together and to analyze the spatial distribution of different areas as from the 15 degrees to the higher Arctic oceans. So this is different. And also we combine the solar radiation data inside to find the results and the relationship between them. You will see this is the temperature totally from the 50 degrees to the Arctic Ocean, and this is the statistic data of the count of our data. So you will find two. This is mostly in this Arctic Ocean, and this is in here. And also we will find the temperature is decreased from this Brindisi Basin to the Canada Basin during the summer seasons of July, the end of July. The salinity is another issue, so we have the data for high frequency, and the average value is 29.4 PSU, and this is more in this side, and this one is in this side. So the salinity also decreased from this issue. So it means the ocean currents is the main way to bring these nutrients, or the main factors to affect the chlorophyll during the summer season, not other factors, maybe. So we just, for sure, we comparing this data with this year's observation is now. So it's the data is from this July 12th to July the 26th before I depart to here, and this is 2 years before. You will find from the here depart from Shanghai to Arctic Ocean, the similar sequence from the 2 years, and the same thing appeared, I think, every year, but some small difference between the 2 years in this, because we have not only stating the same way every year, we have some small changes. So we can think about this. It's very interesting results that we use several key indicators to find the correlation analysis of what is mainly related to the chlorophyll during the summer season, July, in this area. And we find that this one is mostly correlated with the chlorophyll because I have said that the west coast of the ocean currents maybe bring more nutrients to the Arctic Ocean and get this increasing and decreasing of this chlorophyll. And also the radiation in this season, summer season, enough solar radiation, so it's not the limited factor for the bloom or for the phytoplanktons. And So what we are doing now and we will do further is that the same thing happened in Antarctic. This is research result from also the 30th Antarctic expedition of China during 2014 in the end of 2014. We will find the circle Antarctic things, and we will find some area with high primary production or high chlorophyll A areas is in some area with upwelling ocean currents. So it's limited by nutrients also. It's not by the other factors. So this is the area we have modified and selected for the high volume and high value of this chlorophyll A. So what we will do is that to comparing this analysis in Antarctic and Arctic to find some relationship between these key indicators. And also we will, this is the route we have from 2014 to the Antarctic, the same year. So we from Shanghai to come to the Antarctic totally, and also when we are back, we for some Indian Ocean also in the West Australia. And we also want to combine more indicators inside this analysis based on the some data already get with the ADCP and the lowered ADCP to do some estimation and to find some vertical upwelling ocean currents or the north currents from the data. We have this data, but we need the time and need the good method learned from you to have more believable results or valuable results. So that's the work we want to do, and we are trying to do it. So we also have this data availability and cooperation with this website to sharing with you and to get this work to be more broadened, that we can share this data with our, we also have the data sharing platform of Polo Science in China under the management of the Polo Research Institute of China and our Minister of Ocean. So now we come to the conclusion that, firstly, I think based on our monitoring results during this summer in 2014, the chlorophyll concentration points obvious decreasing trend from south to north, and also the similar decreasing trend from south to north is the temperature and the salinity during the summer seasons. So we think that for the phytoplankton growth in this summer season in this area, the salinity means the ocean currents. With the ocean currents from south to the north, it brings the nutrients. So the nutrient level is limited by the ocean currents. It's stronger or weaker, it will be different for every year's chlorophyll in this area during summer, not during spring. We also see the spring bloom, but in summer it's different, I think, phenomenons. So thank you all for your attention, and I will mention that maybe we will have more opportunities to have more monitoring facility on our new Asperik, which will be completed maybe the end of 2018, and have new cruise to Arctic or Antarctic on 2019. And we will be equipped with more monitoring facilities and to share with you. Thank you.